3.5, graphing rational functions. This is going to be part 1. The first thing that we're going to go through is the list of things that you need to find before you graph, and then we'll actually get to the graphing. So please make sure that you write down this list. First up, each time you're going to need to identify the vertical asymptotes. To do that, you set the denominator equal to 0 and then solve. So you'll get answers that are x equals a number, and those equations will represent your vertical asymptotes. Next, you want to find your horizontal asymptotes. To do that, you divide the leading coefficients of the same degree. And when we look at an example, that'll make a little bit more sense. But you'll end up with y equals a number, because horizontal asymptotes will be horizontal. Then we want to locate the x-intercepts. To do that, we set the numerator equal to 0 and solve. So you will get a number and then 0. Those are always written as a point versus the other two that we just talked about that are written as equations. And then, of course, the y-intercept, where you substitute 0 in for x and solved. That's also written as a point. 0 would be the x-coordinate, and the number would be the y-coordinate. Please hit pause to make sure you get all of that written down, and then we'll continue on with an example of a graph. Now, when you're doing these assignments in Schoology, please submit all of this information first to make sure you have it right before you then do the graph and submit the graph, because I don't want you to graph it with wrong information. All right, so let's take a look at our first rational function here. The first thing that we said that we would need to find with any function is the vertical asymptote. And the way we find the vertical asymptote, we set the denominator equal to 0. So we're going to take x minus 2, and we're going to set it equal to 0. We then solve that, add 2 to the other side, so we get x equals 2. Okay, next up, we need to find the horizontal asymptote. And the horizontal asymptote we find by dividing that larger degree, or dividing the leading coefficients of the same degree. So what that means is we have x to the first right here on top, and then we have a corresponding x to the first on the bottom. So x to the first is the largest degree anywhere, and we're going to take the coefficients of those. So we have 1x divided by 1x, essentially. Those x's divide out, and 1 divided by 1 is 1. And a horizontal asymptote will always be the equation y equals, so we would say y equals 1. All right, then we need to find the x-intercept. The x-intercept is when you take your numerator and set it equal to 0. So we're going to solve. We end up with x equals -4, but when we're talking about intercepts, we write those as a point. So we would say -4, 0. And then our last thing that we need to find is our y-intercept, which is where we put 0 in for all of the x values. We get 4 over -2 and 0, -2. Because we write that as a point as well. 0 went in for x, -2 is what simplifies after we take 4 divided by -2. Okay, so like I said, if you were doing this in Schoology, you would want to enter all of these pieces into the computer and make sure that they are correct. And then go ahead and proceed with the rest of your graph. Now, to do the rest of the graph, you need to find 2 points on each side of the vertical asymptote. Okay, so we're going to make ourselves a table here to do that. Our vertical asymptote was x equals 2. So I want 2 points to the left and 2 points to the right. So if this line here is x equals 2, it's not really a horizontal line, but I'll just put 2 there so you don't get confused. So we want 2 points to the left of 2 and 2 points to the right of 2. So to the left of 2 would be 1 and 0, but we already know 0 because of this. So it's actually 1 and -1. And then to the right of 2 would be 3 and 4. If you are more of a visual person, it might help you to actually draw the vertical asymptote on your graph so you can see what we're doing here. So here, let me sketch this vertical asymptote in. You can see that it's at x equals 2. So what we're trying to do is we're trying to find 2 points to the right and 2 points to the left. So we put those in our table. So -1 is -1, 1, -5, 3, 7, and 4, 4. So I'm going to put all the rest of this stuff on the graph. I already have my vertical asymptote. I'm going to put my horizontals at y equals 1. Notice that I'm dotting these lines. That's because asymptotes are imaginary lines. I'm going to put my x-intercept, -4, 1, 2, 3, 4, 0. My y-intercept, 0, -2. And then these 4 additional points. -1, -1, 1, -5 would be this way. 1, 2, 3, 4, 5. 3, 1, 2, 3, 4, 5, 6, 7. And 4, 4. 1, 2, 3, 4. Now when I put those on there, it is much easier for me to see what's happening in this lower quadrant. You can kind of see a curve to a graph. With these 2 points, it's not as easy to see. So I might want to find some additional points. You will also be using the asymptotes to help you out though. So for instance, when I connect these, and I'm going down this way, it's going to curve and get closer and closer and closer to this vertical asymptote. Likewise, when I connect this way, it's going to get closer to the horizontal asymptote. So I can see that whole graph there. It's called a branch. And then I want to do the same thing over here. I'm going to connect through the 2 points, but I'm going to curve them so that they are following the path of the asymptote. All right, so we have our graph, and now we want to identify the end behavior. End behavior came from our last unit, if you remember, as x approaches infinity and negative infinity. So as x approaches negative infinity, what's happening? Well, let's look at our graph, because we're trying to find out what's happening to f of x. So as x approaches negative infinity, that means as you're moving to the left, what's our graph getting closer and closer and closer to? Well, it's this horizontal asymptote. So it's getting closer and closer and closer to 1. Kind of different from when we did that before, and they're always going to infinity or negative infinity. All right, and as x approaches infinity, notice that the stems are exactly the same as when we did it before. It's just the result at the end is different. So as x approaches to infinity, meaning as we go to the right, our graph is getting closer and closer and closer again to this horizontal asymptote. So it's getting closer and closer to 1. Identify the domain and the range in interval notation. So domain is our x values. So if we go up to our graph, start at the left, we can see we start at negative infinity. We go along, we have a graph all the way along here, but then our graph stops at that vertical asymptote. So we're going from negative infinity all the way to 2, and we get stopped. But then the graph picks up again. Once we get to the other side of that vertical asymptote, it picks up. So we go from 2 to positive infinity. Similar process for the range, but range is the y values. We start at the bottom, negative infinity, everything's all good until we hit our horizontal asymptote, and it stops us. So we go from negative infinity to our horizontal asymptote, which is 1. And then on the other side of that horizontal asymptote, we pick up again. So we go 1 to infinity. All right, let's try another one, because these rational functions look very different from each other. There's a lot of them that look like this with the double branches, but as you'll see in our next example, they can look different with 3 branches. We're going to go through all the same steps again. So starting with our vertical asymptote. To find a vertical asymptote, you set the denominator equal to 0 and then solve. So we're going to add 1 and then take the square root. Square root of 1 is plus or minus 1. And it's really important that you remember that plus or minus, because this tells us that we have 2 vertical asymptotes. Then we want to find the horizontal asymptote. All right, this is when we divide that biggest degree thing. So when we look here, our biggest degree is x squared, and there's no corresponding x squared term on top. That means the top has a 0x squared, because that term doesn't exist. On the bottom, we have 1x squared. So essentially, we're taking 0 and dividing it by 1, which is 0. So our horizontal asymptote is y equals 0. Then we want to find our x-intercept. X-intercept we find by taking your numerator equal to 0. So 3x equals 0. Divide both sides by 3. We get x equals 0. Your x-intercept is always written as a point. And then we want to find our y-intercept, which is where we put 0 in for all of the x's. So we end up with 0 over negative 1, which is also 0. And that makes sense because 0, 0 is our origin, so it is our x-intercept and our y-intercept. Okay, so if I start by putting that 0, 0 on there and maybe some of these asymptotes, and I'm going to count by halves. So when I put on x equals 1, I'm going to go 1/2, 1. And here's my vertical asymptote on the right. And then 1/2, negative 1, vertical asymptote on the left. I'm just counting by 1/2 to give us a little bit more space, because my graph is pretty small. And then I also need y equals 0. That is the same thing as the x-axis, so I'm going to dot it just kind of right above the x-axis, simply so that you can see it. But it really would be right on top of the x-axis. Okay, so last time we talked about making a table. And we talked about how you want 2 points on either side of the vertical asymptote. Well, in this case, we have 2 vertical asymptotes. So we need to find 2 points on the left, 2 points in the middle, and 2 points on the right that we don't already have. So to the left of negative 1, we would put in negative 2 and negative 3. In between negative 1 and 1, we already have 0, so we'd have to go halves, negative 1/2 and 1/2. And then to the right of 1, we could find 2 and 3. So you would just take each one of those and substitute them into your original equation to find the y values. I'll go ahead and tell you what they are. Negative 2, negative 1.1. Negative 1/2 is 2. 1/2 is negative 2. 2 is 2, and 3 is 1.1. So we're going to put all of those on our graph. Negative 2. Negative 2. I have to remember that I count by halves on my x-axis. That's negative 2, so this is negative 3. Negative 1/2, 2, positive 1/2, negative 2, and then 2, 2, 3, 1.1. All right, so by themselves, those points probably just look hodgepodge, but remember, we're going to use our asymptotes to help us draw our branches. So these two over here are going to curve like we did on our first graph, curve next to the vertical, curve next to the horizontal. Likewise for the ones on the right side, curve next to the vertical, curve next to the horizontal. And then the ones in the middle do similar things. They use this vertical asymptote, come through the points, and then use the other vertical asymptote. So 3 separate pieces, but they all curve along those asymptotes. Again, we're going to identify the end behavior. So we have our 2 stems as x approaches negative infinity, f of x approaches blank. And as x approaches positive infinity, f of x approaches blank. It's just fancy math notation for as your graph goes to the left, or as you go to the left, what does your graph do? And as you move to the right, what does your graph do? So, if I start in the middle and I move to the left, my graph is getting closer and closer to this asymptote, which happens to be 0. And as I move to the right, my graph gets closer and closer to that asymptote, which also happens to be 0. Lastly, we want to identify the domain and range using interval notation. Domain being our x values. Remember last time the vertical asymptotes stopped us every once in a while. So we go from negative infinity to our first vertical asymptote, we get stopped. We have this piece in the middle, and then on the other side of our second one, we can keep going. So it's going to look like this. Negative infinity to negative 1, stop. Negative 1 to 1, that's the part in between the asymptotes, stop. And then we go to the right, 1 to infinity. Range, on the other hand, is our y values. We start with negative infinity. And even though we have a horizontal asymptote on this one, we ended up with a point that was right on it. So it actually didn't stop us at all. So we can go all the way straight through. Range is negative infinity to infinity. So sometimes you will cross your horizontal asymptote even though you never cross your vertical asymptote.